Hey guys, this is Miss Garner, and this video will be going over square and cube roots. So quickly starting out with some vocabulary, first of which is a square. You should already know this from our exponents unit, but this is anything raised to the second power. So for instance, x squared, it can also be numbers. So 3 squared or 4 squared, anything raised to the second power we call squared. A perfect square is the square of a whole number. So for instance, 3 and 4 squared, those two examples up there, those are both perfect squares. What wouldn't be would, for instance, be like 5.1 squared, because that's not a whole number. That's not what we would call a perfect square. And then cube is, once again, you should recognize it from our exponents unit. We say cube is anything raised to the third power. So x cubed, 3 cubed would be 3 to the third power. 4 cubed would be 4 to the third power. And once again, a perfect cube is the cube of a whole number. So once again, 3 cubed and 4 cubed, those are both perfect cubes because you are raising a whole number to the third power. A couple of new vocabulary terms is we have radical. This is what we call this. It looks like a check mark, and we will be calling that a radical. And then a root is, I like to think of it as the opposite of the square or the cube. So you're trying to think of what number multiplied by itself can get you that number underneath that radical. So for instance, the square root of 100, we're trying to think what number times itself will give you 100. And we know 10 times 10 equals 100. So your answer here is 10. So that's an example of a square root. And just like we have a cube, we also have a cube root. So it looks like the same thing, but it has that 3 up above it. So the cube root of the number 27, we want to figure out what number raised to the third power is going to give you that 27. And we know that answer is 3. So notice how the cube and the cube root are inverse operations, which kind of means just opposite, and the square and the square root are inverse operations. Here, that kind of demonstrated, we have some perfect squares and perfect cubes. So for instance, 3 squared equals 9. I know this because remember 3 squared is just 3 times 3. But if you look on the other side here, you also see that the square root of 9 equals 3. So you see they're just kind of they're opposites. 5 squared equals 25, so we know the square root of 25 is going to equal 5. Same thing with our cubes. We have 2 cubed equals 8, which once again, just a reminder, a cube just means 2 times 2 times 2. And then we can also go the other direction by saying the cube root of 8 equals 2. The best calculator to be using for this unit is this Web 2.0 calculator. You can find this just by Googling that, and it's going to be this very first option here. But you will see that you have these 4 buttons. In the middle here, you have the cube root with the little 3 in front of that check mark, the square root, and then x to the third power, that's your cube, and then x to the second power, that's your square. So that is going to be what we will be using here. So on this first slide, we are just going over how to find our numerical values when we have squares, cubes, square roots, and cube roots. So for instance, 4 squared, obviously we know that's 4 times 4, which equals 16. But if I were to solve it on this calculator, I would press 4 and then that x squared button, and you will see it also gives me that answer of 16. I'm going to skip down here and do this problem, the square root of 100. So we already talked about this one. We're going to say what number raised to the second power gives you that 100. And we know 10 times 10 equals 100. But a lot of these you might not know right off the top of your head. So you're going to press that square root button, type in 100, and once again you will see that it gives you that answer of 10. Okay, so that's an example of a square and a square root. This one right here, 6 to the third power, that's an example of a cube. So this is going to be 6 times 6 times 6. But easier, you're just going to press 6 and press that x cubed button, and you will see that we get our answer of 216. So that's an example of a cube, so a number raised to a third power. And then the last example is, we will do this one right here, which is the cube root of 512. So this is what number raised to the third power gives you 512. So cube root, I'm going to type in 512, and I get the answer being 8. So if I want to check myself, I can just do 8 to the third power and make sure that that equals 512. So for this first slide, all we are doing is we're trying to find the numerical value for these numbers on the left. Moving on this slide, we will not be using our calculator. Instead, you will see that it says the word estimate. So estimate just means get as close as possible. And we're going to do this by using our perfect squares. So you see this table up here shows all of your perfect squares. So for instance, 1 squared will give you 1, which is under our radical. 2 squared gives you that 4. 3 squared is 9. 4 squared is 16. 5 squared is 25, and so on. So you will see that this whole table is showing your perfect squares. So all of our examples now are going to be numbers that aren't perfect squares. We're trying to estimate them. They're not going to be whole numbers. But what we can do is we can use those perfect squares to try to get close. So our first one here, the square root of 30, I'm going to look at that number under the root, which is a 30, and I want to try to place it somewhere here. I want to put it in between two numbers. So I know 30 is bigger than 25, but it's less than 36. So it's got to be somewhere in between there. And I also know it's going to be pretty much close to the middle, right? It's pretty much in between 25 and 36. So that means my answer is going to also be somewhere between 5 and 6. So 5 squared is 25, 6 squared is 36. I know the square root of 30 is going to be somewhere in between those. So since it's pretty much in between them perfectly, I'm going to estimate that as about 5.5. Once again, we do not want to use our calculator for this, but just for the sake of this, I want to prove the square root of 30, we estimate it as 5.5, and you will see that it's 5.477. So we got pretty close there. So another example here, I'm going to do the next one, the square root of 50. So once again, I want to take that 50 and I want to try to place it within my perfect squares. So this time, I know it's bigger than 49, but it's less than 64, so it's in between here. And notice 50 comes right after 49. It's going to be really close. It's going to be right after it. So that means I'm going to have an answer that's going to be right after that 7. So I'm going to estimate that to be about 7.1. Because that 50 comes right after the 49. So I know my answer here is going to have to come right after the 7. Once again, if we wanted to check our answer here, the square root of 50 is 7.07. So once again, if we round up, that would be a 7.1. So we are estimating here by trying to place within our table where that number would go. On this slide, you will see that it says solve for x. So anytime you see this solve for x, you should have solved equations last year in 7th grade, and you should be familiar with inverse operations. So just a quick example, if you had the problem x plus 5 equals 10, so this is a problem from 7th grade, you should remember that the inverse operation here would be to subtract 5 from both sides. All right, when you subtract 5 from both sides, you cancel out here and you get x equals 5. We're going to do the same thing for these problems. Our inverse operation just means to do the opposite. So for example, number 9 says x squared equals 36. Well, the opposite of a square is a square root. So when I do that square root, those kind of go away, leaving me with just an x equals. And whatever I do to one side of the equal sign, I have to do to the other. So I'm going to do the square root of 36. So I can do that in my calculator if I don't know it in my head. So the square root of 36 equals 6. So x is going to equal 6. Another example, number 12 here, I have that x cubed equals 27. Well, the opposite of cubing is taking the cube root. So I'm going to take the cube root of both sides. On the left, remember, that's going to cancel out. That's going to leave us with just an x. And then on the right-hand side, I'm going to do the cube root of 27, which is what number raised to the third power gives you that 27, which is 3. Okay, so that's going to be solving for x. You're going to do what we call the inverse operation. So it's think of doing the backwards thing to get back to x being by itself. And then our last one, same thing, we are solving for x by still doing inverse operation. So number 15 here, we have square root of x equals 7. Well, the opposite of a square root is to square it. So those will cancel out. And remember, whatever you do to one side, you have to do to the other. So 7 squared is going to equal 49. Number 18, I will also do that as an example. The opposite of a cube root is to cube it, right? That means raise it to the third power. That will cancel out. I'm going to raise 3 to the third power. So I'm going to go, what is 3 raised to the third power? So 3 times 3 times 3. That equals 27. Okay, so notice when I did those operations, I had just one number on that right-hand side, and on the left was just that x term. Numbers 17 and 20 are a little bit trickier. They have one extra step. So you will notice there's square root of x plus 8 equals 10, and cube root of x minus 1 equals 5. So we have to do one step first, and that first step is what you did back in 7th grade when you were isolating for x. So here I have a plus 8. I want to get rid of that, so I'm going to do the opposite. So I'm going to subtract 8. And remember, whatever you do to one side, you have to do to the other. So I'm going to subtract 8 from the other side. So on the left-hand side, plus 8 minus 8, that's going to go away. That cancels out to 0. So I'm left with the square root of x equals 10 minus 8 gives me 2. Now, this problem looks exactly like the problems we just did. The opposite of a square root would be to square both sides. So I'm left with x equals 2 squared, which is 4. So notice that number 20, you will also have to do that one extra step. So the main thing to take away is the relationship between a square and a square root, and a cube and a cube root.